Java Programming Overview. Build and deploy Java applications at scale. This nanodegree program is intended to elevate your Java abilities and teach you the fundamental skills used by Java developers to design, code, test and deploy cutting-edge Java software. It is ideal for programming beginners with little or no Java experience who want to set themselves up for success as a professional Java developer and deploy functional Java-based applications of their own creation. A graduate of this program will be able to apply basic features of Java programming language, data types, variables, conditional statements, loops, methods, to develop applications. Use IntelliJ IDE to develop and troubleshoot Java applications. Design and create classes and class methods in a Java application. Apply interfaces, inheritance, and polymorphism in Java applications. Select and use collections, lists, maps, sets, etc., and basic features of functional programming, lambdas, streams, optional, to organize and process data. Apply advanced concepts, reflection, class loading, etc., to implement advanced Java applications. Prerequisites: you should be familiar with basic programming concepts like variables, loops, conditionals, arrays and methods. Estimated time, 3 months at 10 HRS/week. Prerequisites: no prior Java experience is required. Course 1 Java Fundamentals. In order to be a great Java developer, you must first learn the fundamentals of Java. This course introduces the fundamental concepts and practices of Java programming. These include basic object-oriented programming, OOP, concepts such as classes, encapsulation, and inheritance, as well as core Java concepts such as collections, exceptions, and commonly used Java types. Project 1 Hotel Reservation Application. Students will be designing and implementing a hotel reservation application. The hotel reservation application will allow customers to find and book a hotel room. Rooms will contain the price along with the dates that the room is reserved. All room bookings will be associated with a single customer account. The customer account will include the customer name, first and last, and email. The application will allow customers to retrieve a list of the hotel's free rooms. In addition, the hotel reservation application will allow customers to find and book rooms based on availability and price. Lesson 1 Java Programming Basics. Understand keywords and how they are used in Java. Be able to declare variables in Java. Describe the difference between primitive variables and objects. Apply casting to change the type of a variable into another type. Understand what truncation is and why it occurs. Create a method in Java. Describe the difference between stack and heap memory. Know the 4 different access modifier types. Create an array to store primitive variable types. Create each of the 3 different loops, while, do while, and for, to iterate over an array. Create a Java program in IntelliJ. Describe the purpose of JavaDoc. Lesson 2 Defining classes. Explain what an object is and why we use them. Describe the differences between a class and an object. Know the parts and syntax for creating a class. Create different objects from a specific object type. Describe the purpose of garbage collection in Java. Lesson 3 Object-oriented programming. Describe what packages are in Java and why we use them. Apply inheritance to share behavior and state between related classes. Apply polymorphism in Java to support decoupling. Describe the difference between an interface and abstract class. Lesson 4 Common type. Apply throwing an exception from a method when an issue is discovered. Create an exception handler to catch and handle an exception. Use enums to provide a predefined selection of constants. Use the Java Scanner class to read input from the console. Apply Java Data and Calendar class to store and manipulate day and time. Use the Java regex package to validate the input of a string. Use some of the advanced methods of the string class to create substring, search for text and investigate different characters of a string. Lesson 5 Generics and collections. Describe the purpose of using generics in Java. Create a generic method that processes different class types without casting. Apply generics to collections to create stronger type data sets. Use data structures that implement the collection interface. Use the collections utility class to sort a list of strings. Lesson 6 Advanced Java types use maps to store and retrieve data based on a key value. Use sets to remove duplicate values from a list. Use a queue to store values in a FIFO manner. Course 2 Advanced Java Programming Techniques. The best Java programs combine excellent software designs with modern language features. This course will teach you some lesser-known features of Java such as functional programming, I/O serialization and reflection. Strengthen your software design intuition by exploring the design ideas that underpin understandable, extensible, and scalable software systems. Learn basic concepts and techniques of concurrent programming in Java so your programs can take advantage of modern multi-core hardware. Project 2 Legacy Web Crawler Concurrency is a powerful tool to increase the performance of your Java programs. In this project, you'll use concurrent programming techniques to enhance a legacy web crawler so that it can take advantage of multi-core architectures. The crawler will read configuration from a JSON file, download and parse multiple HTML documents in parallel, and record popular web terms in an output file. You'll also build a method profiling tool to measure the efficiency of the crawler and prove the benefits of the parallel crawler. Lesson 1 Functional Programming in Java. Understand the differences between imperative and functional programming. Use functional interfaces, lambdas, and method references to simplify and improve your Java code. Apply Java Stream API to perform quantitative analysis over large sets of data. Lesson 2 Working with Files and I/O. Understand the differences between program memory and persistent storage. Know the different uses of binary and encoded data and understand when to use each. Use the Java Files API to read and write files. Recognize different kinds of resource leaks and apply modern Java techniques to prevent them. Serialize and deserialize between Java objects and common formats like JSON, XML, and binary. Lesson 3 Design Patterns. Identify the principles of good software design and build strong software design intuition. Understand what design patterns are and why they are useful. Use creational, behavioral and structural design patterns to write flexible and easy to understand code. Apply dependency injection to simplify object creation and promote testable designs. Lesson 4 Reflection. Use reflection and annotations to introspect and add dynamic capabilities to your programs. Implement Java interfaces at runtime using dynamic proxies. Understand the fundamentals of aspect-oriented programming. Use class loaders to customize how Java loads bytecode. Lesson 5 Introduction to Concurrent Programming. Recognize when concurrency can help improve the performance of Java programs. Use threads, thread pools and parallel streams to achieve parallelism in Java. Apply Java synchronization tools to correctly share state between threads in a parallel program. Course 3 Java Application Deployment. This course introduces Java ecosystem topics that are necessary to develop production-ready applications. It starts by covering the construction and makeup of Java program artifacts. You will learn how Java program code is compiled, packaged, and executed. Next you'll learn how to use Maven to automate and customize the build process, as well as manage external project dependencies. This course also covers the topic of modules introduced in Java 9. In addition to build topics, this course will also teach you to use the tools of JUnit 5 to write unit tests and evaluate code coverage. To expand our testing capabilities for complex applications, the Mockito library and test doubles will be covered as well. Project 3 Security. To practice all the skills covered in this course, you will start with an existing project that needs help. The Security program is a basic GUI application that allows users to perform various tasks related to managing their home security system. In order to prepare to scale the software, it's going to need some revisions. You'll need to refactor the program into a multi-module Maven project, and you'll also be writing unit tests to verify that it actually does what it claims to do. You'll be using the JUnit 5 and Mockito libraries we cover in this course to write a full unit test suite for the project. Lesson 1 Running Java Applications. Learn to use the tools of the JDK to compile, package and run Java applications. Recognize and evaluate bytecode. Use the JShell application to execute arbitrary Java code. Lesson 2: Dependency Management with Maven. Read and write well-formed XML, including Maven pom.xml files. Use Maven to build Java projects and include external dependencies. Use Maven plugins to modify the build process and perform additional tasks such as generating API documentation and executing static code analysis. Lesson 3: Java Modules. Identify and create Java 9 modules using the module descriptor class. Convert existing projects into module format. Use the JLink tool to create a custom JRE for a specific Java module. Lesson 4: Unit Testing with Java. Explain the benefits of automated testing and identify the steps in the unit testing lifecycle. Write unit tests utilizing the features of JUnit 5 to cover all program requirements. Run unit tests automatically with Maven. Use tools in IntelliJ to identify any missing code coverage from your unit tests. Lesson 5: Mocking and Integration Testing. Identify and create test doubles to isolate testing requirements from their dependencies. Use the Mockito library to create and modify the behavior of test doubles. Understand the roles of unit testing, integration testing, and functional testing in the automated testing process. Create mock endpoints using wire mock to isolate testing requirements from external API calls.